Hello, good day and welcome to Joso. My name is Edwin and this is the part 3 on our series of how to carry out a bathymetric survey. So we've talked about the introduction, the equipment that you need for the bathymetric survey. We've also talked about the connections, how to do your connections. Now on this video we'll be talking about how to acquire your data. Your basic operations on how to acquire your data is what we'll be doing today. So do well to follow us on all our social media platforms, hit the subscribe button and like. You can share, comment your suggestions about this video and as well what you would like to see on our next video. Thank you very much, and let's proceed to the exercise that we have. Okay, so as you can see, we've done all our connections already. This is our Echosounder. This is our battery powering the Echosounder and every other thing connected to it. This is our GNSS receiver, the one that is providing the XY coordinates for our sounding locations, and then we have our transducer inside the water. This is our boat clamp. We have our mouse, and this is the controller for our GNSS. So these are the equipments that we are making use of, and of course we've done the connections already. Please don't forget, it is also important to wear a life jacket and then the boat that you are using to navigate. So now we'll be talking about how to do your operations and how to acquire your data. So the first thing we are going to do is we are going to launch the application on our Echosounder. So the application we use for bathymetric survey is the iSurvey, which is this app. Also, it has a partner application, which is the Echosounder. So by clicking on iSurvey or by launching the iSurvey app, the Echosounder tool will open by default. So what we need to do here is to create a job. So by creating a job, we just type in the name of the job we want to work on. So for this test we are doing, we are using a bathymetric survey test. So this is going to be the name of our project. So, and it's going to be a new project, so we'll click on new project and then we'll click on OK. So after clicking on OK, it will come to the second window where we'll select our path. Now the path is the storage location. So ordinarily, if you've created the folder for your job, you just go to where the folder is and select the folder. But for now, we are going to use our default saving folder, which is a computer iSurvey 2016 data. So this is going to be our default saving folder. So we'll click on choose. We'll click on, if you want to input the details of your builder, the job location, of course the date is already there by default. If you want to add the surveyor and any remark that you have, you can type those information into this checkbox, into these boxes. The next thing we are doing is we will go to coordinate. You can come directly to coordinate or you can click on next. So when we come to coordinate, we'll select the coordinate system that we are using. For this test, we are making use of UTM zone 31. If you have a coordinate system that is not here, you can come to new to create the coordinate system. You enter the coordinate system name, you set your projection and the parameters and everything, and then you are good to go. But if you already have it here, you just select from the list you have and then you click on next, or you just click on device to move to the next page. Now on device page, we are going to select the various devices we are using. So the devices we've connected to the Echosounder is the transducer and the GPS. So for the GPS, we are using COM port 2. If you check on the right side of the Echosounder, this is our GPS cable connected to the GNSS receiver and is plugged on COM port 2. So when we come to our GPS, we check this box and then we'll come to setup. Sorry, we'll select this to become port 2. Check the bus and we'll come to setup. Now when we come to setup, we are going to hold there, come to our GNSS controller. Now on our GNSS controller, the first thing we are going to do is we are going to connect to the GNSS receiver that we are using for our project. So is this
device connected. Rover.
So now it's connected.
PDA
the next thing we are going to do is to create a project. Well, we've created a project already, which is this battery test that we are doing. So we'll select the project, click on open. We're already on the project, so that's all. Another thing is you need to make sure the project on your GNSS controller is the same as the coordinates you use on your Echosounder. If not, your coordinates will not match. So let's check our coordinate system. As you can see, we are currently on Mina UTM31, so we are good to go. Now we'll go to our rover setup. Here we'll connect our GNSS to our base. Now you can use your GNSS receiver base, you can use a call station, you can use any base of your choice, but for this test we are using a call station. So we'll come to rover, select the call station that we are making use of, and then we'll click on apply. So selected our call station, and as you can see, it is fixed already. So the next thing we are going to do is we want to send the correction data from the GNSS to the Echosounder. So we'll come to, on that same device page, we'll come to more. We'll click on 0183 output. We'll select that. The NMEA output port, we'll make sure it is on serial. After that, we'll click on OK, and if we click on disconnect, it will disconnect from the GNSS, and we don't want that because the internet we are using is from the controller. So we just click on cancel. Keep this aside. Then we'll come back to our Echosounder, select our GPS. Now we do not have the customized name of this GPS we are using, so we'll just select other GPS. After that, we'll come to serial parameters, check if the parameters are okay, and then we'll click on test. Now when you click on test, we're supposed to be getting these values, and they by default they're supposed to be changing, meaning the correction data is coming. So once we check and it's okay, you can click on stop. If by adventure it was not coming, let's say we use a different port, and we click on test. Let's clear this. Stop. Clear. We click on test. See now no correction data is coming in, so we are using the wrong port. So let's stop this again, change our core port to 2 that we were using initially, and then we'll click on test again. As you can see, the corrections are coming back now. So we'll stop this, go back to GPS, and then we'll click on OK. Now for our Echosounder ports, it is already set by default, so we don't need to do any setup there. Now the next thing we are going to do is either click on next, or we'll come to collect. Now the collection is to define how you be collecting your data. Now for the GPS, if you want to collect when it's on single, you select single. If you want to select when you collect data when it's on fixed, on float, you use ROTD. But if you want it to be only on fixed, you select ROTK. So we are using ROTK because we want it to be on fixed. Then secondly, for how you are collecting your depth data. Now if you check, we have automatic collection and manual collection. So we are using the automatic collection. So we check off the manual and we click on automatic. Now there are 2 modes. If you want to use time interval, it means that if you count, now the time interval is on 3 seconds, so it will be registering the depth point every 3 seconds. Another way is by distance interval. Now the distance interval is showing 5 meters. Now if you move from one point to another point 5 meters, it will register a depth value. So we are going to use, for this test, for the sake of this test, it is preferable to use distance interval, but for this test we are going to use time. So we'll select it to change it to time, and then we change our time interval to 5 seconds. So we are using 5 seconds and it's time interval. So we'll click on next. On the antenna height, we don't have any setup we are doing here, so we just click on finish. Now we'll finish the setup we need to do on our height survey. The next setup we are doing is on our Echosounder application. So we'll come to Echosounder. The first thing we are doing is to set our parameters. Now if you click on default, it will show you drought is 0.5, velocity 1.483, the shallow alarm is 00, and then there's echo alarm is closed. Now let's explain what is happening here. Drought means the amount of, or the depth that the transducer is entering the water from. Now if you check on this transducer pole, let me bring this out. Now if you check on this transducer pole, it is calibrated. Now the bottom here is 0. The first mark line we have here, from here to here, is 0.1. so if your pole is going into the water to this point, your drought will be 0.1. if it's getting to this point, is 0.2, this is 0.3, this is 0.4, 0.5 is somewhere around here, and so on and so forth to 1 meter. Now your drought is based on how your pole is entering the transducer, is how deep the transducer is inside the water. So we are going to put it back inside the water to measure our drought level. Now as you can see, I'm going to bring it out again, so that this is 0, and this is 0.1, this is 0.2, this is 0.3, and is a little bit more than 0.3, so we are going to approximate that to be 0.32. so our drought is going to be 0.32. So now we are going to enter our drought here to be 0.32. now for velocity, we'll come back to velocity. Then the next thing we are going to set is the shallow alarm. Now this is just an alarm that comes up anytime you're going towards an area that is not deep. So it will set it to a range. So if you are setting it to 1 meter, once your boat moves to a place that is not as deep as 1 meter, it will give you that alarm, meaning you are going close to a parts that are not deep. Now it helps you to navigate and also avoid hitting anything that may damage your transducer. So you might want to set this at a level a little bit higher than what you set at your drought. So since we have our drought at 0.3, we can set our shallow alarm to be 0.4. so we are using 0.4, or we can even use 0.35 since we are not inside the water now. But for safety reasons, you should have at least 5 meters extension from where your transducer level is. So by normal, if you want to do it inside, if you are using a drought of 0.3, your drought should be at least 0.8, so that you can have 0.5 distance between your shallow alarm and where your transducer is. So but for this test, we are going to use 0.4. The next thing we are going to do, the echo alarm is just as you are sounding, it will be beeping. It's just a means of ensuring that your sounding is going on without disturbance. So we'll apply this, we'll close this, and then we'll start recording. Now when we start recording, it's going to ask us to save the recording, the depth that we are getting. So we'll just quickly type in a name for this. So we are using bathy survey survey test. Sorry, I'm using bathy survey tests, and then can close this, and then we'll click on OK. So we've created the file. Now, as you can see, it's recording the depth of the water. Now we'll also come back again to parameters. We want to adjust the frequency to get the correct depth of what we have. Now this method or this process is what we call batch check. It's just a way of ensuring that you are getting the accurate depth measurement from your Echosounder. To do that, we'll measure manually. Now for the batch check, we are using a instrument height tape, H height tape. You can use a leveling staff, you can use a fiber tape. You just tie weights to the edge and then you drop it inside the water. You can use any device or anything that you can use to measure the accurate depth of water, but for this test we are using the H height tape. So we'll put this inside our water. We'll measure to the bottom of the water. So what we are getting here is 6.4. So what we are getting here is 6.4. So that is 0.64. Now we are going to adjust the velocity here until we get 0.6. So first we are going to change this to 1000, and then we'll click on apply. It's going down, but it still has not gotten to what we need, so we'll change this to 500. Click on apply again. See, now we are getting 0.64. So we are good to go. So this is going to be our velocity of water. So click on apply and then we'll click on close. You see, now we are getting the shallow alarm because we set it to a place that the Echosounder is not far from where the transducer is. The seabed is not far from where the transducer is, so it's giving us the shallow alarm. If you want to stop this, you can reduce your shallow alarm. Let's put this to 0.3. Click on apply. See, it has gone off. So we're getting that beep because the Echosounder is sensing that the place is in is not deep at all and it's close, is beyond what we set. So that was why we're getting the alarm. So we'll apply this and then we'll click on OK. Now the next thing we are going to do, you need to set your depth range. Set it to automatic change, so that when you go to an area that is very deep, it will measure accurately. When you come back again to area that is not as deep, it will also measure accurately. The next thing we are going to do, we are going to come back now to our high survey since we've started getting our accurate depth. Now to connect the high survey, will merge the data coming from the Echosounder and also the XY coming from the GNSS to get our sounding position. So to do that, we click on this green icon, which is the device connection. So once we click on it, you see we are now getting our XY coordinate. Let's put this to full screen. See, we are getting our XY coordinates here. This is our XY coordinates and this is our depth value. This is our northings, this is our easting, and this is our depth. So we can now, from here, we can check on our controller. See, we are getting on our topo survey, we are getting the northings at 714.105.106.105. So that is accurate. The next on our list is the easting. We are having 565673. Here is also 565673.390391. So it's the same thing we are having on the screen. So we are on point.
Not fixed.
Now going to float. Next,
Fixed.
so it's fixed. need to send the output again. Okay, so our xy and our depth is coming here. So now, to as you can see, our boat is showing on the screen now. This is our boat. This is the location of where the boat is now. Now, to start recording our data, we'll click on start recording. It will start picking the points. So I think if we move a little, see, it has moved a little. We do not have much space. If we come like this, we do not have much space. That's why we are not seeing it clearly, but that is how to do your job. Now, when you finish, maybe you finish sounding all the areas that you want to get the data for, you just come to stop recording. At intervals, you can pause, you can also continue, and finally, when you are done, you can stop recording. Now, when you stop recording, you finish getting your data. What you have to do next, you need to save. It is very important to save. When you click on save, it will save. Now, to be sure that the data you've done has saved, you come to processing. So you come to tools, you click on raw data. So this is the data that we've measured now. You click on OK or open. It will show you these are the points that we've picked. Now we know we set it up at seconds interval, so we have up to 64 points now, and these are the data for the points that we picked. So that is it. Now, after, to be sure again, we click on save again. So after that, you can close and stop the connection. Stop the connection. Sorry. You can stop the connection and close your high survey. You want to exit, you click on yes. Also, you stop recording here. Then you also need to save this as well. Okay, if you want to save this, you have to, when you click on cancel, to ask you to exit, click yes. So it will save the file before you exit. So that is how to do your bathymetric survey to acquire your data on site. So on our next video, we'll be talking about how to process the data that you've acquired on site. So stay tuned. Make sure you like, share, comment your suggestions about this video, and as well follow us on all our social media platforms. So thank you very much, and do have a wonderful day.